Hello. How are you doing? Babe, thank you. Okay. All right. Are you guys able to see the PowerPoint? Oh, it looks like I need to get the connection a little bit better. Jonathan? Okay. Mhm. Okay. Are you guys able to see the PowerPoint? Okay. Thank you very much. All right. I don't exactly remember where we left off. I know we did some of these early problems. So here's the stem and leaf plot that we did. And then we were given a stem and leaf plot. We made a histogram. And then we looked at precipitation in Portland and New York City. Pretty sure we did that one yesterday. And then we did the car problem. Does that look familiar? Okay, did we look at this problem, do you remember, with the different populations? Okay, we already did that one, thank you. Okay, and so we figured out Bombay had the largest percent increase and Rio de Janeiro had the smallest. Do you remember looking at this problem where we had the public school expenditures and we made the line graph? And we came up with a line graph that looks something like this. And then we made the second line graph where we basically stretched it out. Okay, we already did that one. Thank you. All right, and then on the circle graph, we figured out taxes were the largest source of revenue. And we found the central angle. Did we do this one already? Yep, already saw that one. Okay. Okay, and then number 13. I don't think we did this one. Did we do this one? We knew the total revenue was $4,500,000,000. And then we had to figure out how much was spent on each category. So we knew the grants to the local governments, that was 28.2%. So to figure out how much money was spent, we can set up a proportion and solve this for X. And so we find out that $1,269,000,000 was spent on that category. And then next we have salaries and fringe benefits, which is 25.8%. And again, we can set up a proportion to figure out the amount of money. And so we get $1,161,000,000. And then we're looking next at the grants to individuals and organizations. We know that is 19.4% of the budget. And so we set up our proportion. And we find that $873 million is spent in that section. Then we'll do the operating part. That was 13.8%. And we'll set up a proportion. And we find out that $621 million is spent on operating. And then the other, we know that's 12.8%. And we can set up a proportion to solve that. And we come up with $576 million worth other. Did anybody have any questions so far about anything? Okay, next we're going to look at a pictograph. So we're given this graph. You know that each mining car stands for $10 million. About how many dollars worth of bauxite was mined? We know that it's more than 10 million. Okay, each car represents 10 million. So if we have 1.5 cars, we get $15 million. And then next we're going to do sand and gravel, and that's about half a car. So that would be about $5 million. And then for petroleum and natural gas, we need to count up how many cars there are. And I think there's 8.5 cars. So that is $85 million for petroleum and natural gas. And then next, we have some data on the public school enrollments, right? And we're going to choose an icon and a reasonable amount for it to represent and make a pictograph. So we're going to be making a graph like the graph we had on the last problem. And now keep in mind that for the year 2000, we have 47 million. So if we choose an icon and have it represent 1 million, we'd have to draw 47 of them. So 1 million, even though it seems like a large amount for the icon to represent, it's probably not going to be big enough because we don't want to draw 47 of an object. Okay, and it is public school enrollment. So we could have a stick figure person. And then we can let each person represent 5 million people. Okay, so for this one, we have about 17, almost 18 million. So if we draw 3 stick figures, that would represent 15 million people. So we'll need somewhere between 3 and 4 stick figures for this one. And then for the 47 million number, if each stick figure represents 5 million, we would need 9 stick figures, and that would represent 45 million. So we're going to need somewhere between 9 and 10 stick figures. Okay? So here's a pictograph. Okay? And remember, we said we needed between 3 and 4 little stick figures for 1910, and between 9 and 10 stick figures for the year 2000. And we have this little legend. So either up here or down here, we know how much each little stick figure represents. Then it says, in which decades were there increases in enrollment? So we can tell that in 1920, we have a bigger amount than in 1910. So throughout the 1910s, there was an increase to get us from 1910 to 1920. And then we can see that the number in 1930 is bigger than the number in 1920. So throughout the 1920s, there's an increase. Okay, and then we can tell that the number in the year 2000 is larger than the number in the year 1990. So throughout the 1990s, there's an increase. So from 1910 to 1920, so throughout the 1910s, from 1920 to 1930, it increases. So throughout the 1920s, and then it's larger in 1960 than it was in 1950. So that means that it was increasing during the 50s. And then 1970 is bigger than 1960. So the numbers were increasing throughout the 60s. And then the number is bigger in the year 2000 than it was in 1990. So the numbers were increasing throughout the 1990s. And then we want to think, well, what other kinds of graphs could we use to represent the data? We could have used a bar graph or a histogram, right? And those actually probably would have been a little bit easier because we wouldn't need to actually draw the little stick figures. We would just need to make a bar that's the correct length. For number 16, it says the college admissions office uses high school GPA as one of its selection criteria for admitting new students. At the end of the year, 10 students are selected at random from the freshman class, and a comparison is made between their high school GPAs and their GPAs at the end of their freshman year. And first, we're going to make a scatter plot of the data. So that's the sort of graph that you're probably used to making, where you have a number that represents X and a number that represents Y, and you put a dot on the paper for that X and that Y. So it's going to look a little something like this, where our X's will be the high school GPA, and the Y values will be the freshman GPA. So here's a scatter plot of the data. We just have the 10 dots, one dot for each student. And then the next piece is to sketch the regression line on the scatter plot. So a regression line, that's really sort of a best fit line that's going to capture the trend in the data. All right. It's just a straight line that best fits the data. So here's the regression line, and in general, we'll end up with about the same number of dots above the line as below the line. And we can see that these two GPAs are positively correlated. And what that means is that the higher somebody's high school GPA is, the higher their freshman GPA is. And we can tell because we have a line that's an increasing line. It goes up when you look at it from left to right. Are there any questions about anything so far? Problem number 17 says students taking a speed reading course produce the following gains in their reading speeds. So we've got several students. One student who's only been in the class for 2 weeks and they have gained 50 words per minute. Then we have two different students who've been in the class for 4 weeks. One gained 100 words a minute and the other one gained 140, and so on. And then the first thing we're going to do is to make a scatter plot for the data, just like we did on the last problem. So the weeks will be the X's and the speed gains will be the Y's. So it'll look kind of like this. Here's our scatter plot for the data. And then just like on the previous problem, we're going to make a regression line. All right, so that's going to be a best fit line, a straight line that pretty much fits the data. Okay, and here's our best fit line. And we can see that the number of weeks that someone's been in the program is positively correlated with their speed gain. And that just means that the more weeks someone's been in the program, the more speed they've gained. And again, we can see because the line is an increasing line, it goes up from left to right. And then number 18, this should actually say a golf course professional collected the following data on the average scores for 8 golfers and their average weekly practice time. So we know how long they've spent practicing in hours every week and their average score on the golf course. And we're going to make a scatter plot. All right, so our X's will be the number of hours they spend practicing, and the Y values will be their score. All right, so here is, we've got the scatter plot as well as the regression line together. And this time, we've got a line that goes down. So that means that the two things are negatively correlated. As the practice time increases, their average score decreases, okay? But note that in golf, a lower score is better. So the longer they spend practicing, the better their score is because they do want to have a low score. Any questions so far about anything? Okay, next, it says, number 19, a company that assembles electronic parts uses several methods for screening potential new employees. One of those methods is an aptitude test requiring good eye-hand coordination. The personnel director elects 8 employees at random and compares their results with the average weekly output. All right, so somebody whose aptitude test score was 6 has a weekly output of 30 dozen units. And then somebody whose aptitude score is 9 has a weekly output of 49 and so forth. And we're gonna make a scatter plot and probably put in a best fit line. So our scatter plot's gonna look like this. The X values will be the aptitude test results, and the Y values will be their weekly output. So here's the scatter plot with the regression line. And we can see that the two variables are positively correlated. As the score on the aptitude test increases, the weekly output also increases. Okay, on number 20, it says a doctor conducted a study to investigate the relationship between the weight and the diastolic blood pressure of males between 40 and 50 years of age. Right? So he's already collected some data, he's plotted his data, and he's put in a best fit line. Okay, so we have the scatter plot with the regression line. What we want to do is we want to predict the diastolic blood pressure of a 45-year-old man who weighs 160 pounds. So notice that this data was collected for males between 40 and 50. So the data applies to a 45-year-old man. We know his weight is 160. So we'll start at 160 for weight. We'll go up to the regression line, and then we'll come over to see where does that, what blood pressure reading does that give you? All right, so we start at 160, come up to the line, and then come over to the y-axis. And that gives us about 84, okay? And next, we want to do the same thing. We want to predict the diastolic blood pressure of a 42-year-old man who weighs 180 pounds. So again, the data is about men between 40 and 50, so it would apply for a 42-year-old man. And we know his weight is about 180. Here's 140. This would be 150, 160, 170, 180. So we're looking right here on our x-axis. We're going to come up to the best fit line and then come over to the y-axis. And it comes out to be about 89 or 90. That makes sense to everybody? Anybody have any questions so far? Okay. Number 22 says the projected enrollment in thousands of public and private schools in the United States in 2015 is given in the table. So we know the number of elementary kids in public and private, number of secondary, that means high school in public and private, and then the number of college students in public and private schools. And the first question is, what's an appropriate type of graph to display the data? So we want to compare the two different types of schools, the public and the private, and the enrollment at the three different levels. So we could use either a double bar graph or pictograph for this. And then next, we need to actually go ahead and do that. So I did a double bar graph where the purple bars are for the public schools and then the white bars are for the private schools. And it's pretty easy to see that there's way more enrollment in public schools than in private, but that's especially true at the elementary level, right? The bars get a little bit closer the further along you go. Next, number 23 says the federal budget is derived from several sources as listed in the table. So we have our individual income taxes, almost 50%, the social insurance receipts, about 35 or 36, corporate taxes, 3.1, and other is 6.1. And we want to do the same kind of thing, figure out an appropriate graph. So I would say a circle graph, which is also called a pie chart, is best because we want to see how each part compares to the entire budget. And we'll be able to see the relative size of each of those revenue sources. And then the next thing is to actually go ahead and do that. All right, so we've made a graph of the data. And one thing to note, it said individual income taxes was 47.4, but on the graph, I went ahead and just rounded that to 47. So I've rounded the percents to the nearest whole percent. So 35.5, I'm giving as 36%. Okay, and I think that's good for today. Did anybody have any questions about anything? Okay, so remember that you do have homework on MyLab and you also have a quiz to work on. Please let me know if you have any questions about anything or if MyLab gives you any troubles. I hope everybody is doing okay and staying safe and healthy. Anybody need anything from me? Okay, I really appreciate everybody coming today, and I'll see you again tomorrow. Please let me know if you have any questions about anything. Thanks, guys.